Alright, I think we're live. So if you weren't here for the last live stream, this is a Sentec power amplifier, audio amplifier that has an issue where it's just got one half of the output waveform coming out of one of the channels. And in the last live stream we concluded that there's no issue with the power transistors, or at least there seems to be none. So today I figured I've done some tracing and I've figured out a couple of possible culprits. This could be any of the driver transistors in the driver stage, or it could be a bunch of resistors causing this. We measured through all the diodes and stuff, and most stuff seems to be in good working order. So I'm suspecting either a driver transistor or a bad resistor. So let's just get going. And we have a few people showing up, and that means everything's working fine. Hello, chat. Hello, Brandon C. So let's see, we've got resistors R41, R37, R45 and R49, which are very likely culprits. They're all resistors coupling the pre-drivers, the drivers, or the outputs of the drivers to the power transistor. Since in the last stream we tried connecting up this power amplifier with no power transistors, and then it seemed to work fine. So it is able to put out a clear, clean sine wave as long as there's no load on the driver transistors. So we've obviously got an issue which is only present when there's an output current going through, which is why I'm suspecting resistors, but it could also be bad driver transistors. I was very tired while doing the last bit of troubleshooting on this, so I don't even remember half of the stuff I figured out. I do remember that the numbering on the channels is kind of weird though, so let's start with R42, if we can find that somewhere. Good evening, sir. Glad to have you back. Glad to have you viewing. 21 people. What's the date code on those large axial caps? There is none, but this is going to be late 70s vintage. R42. I don't think you got an actual layout on this board, so it's a bit annoying. Yeah, that's 100 ohms as it should be. So R42 is unlikely. R38 should be in the same area. Is that R38 or is it R36? I think that's R38, also 100 ohms. Or 10 ohms. 40 ohms across that. Brown, black, brown, gold. Oh, I'm bad with a 4 bands. Let's cheat. Mescal. That's a good software you told it, by the way. Mescal. You Google that. It will do all your color codes and Ohm's law and stuff for you in a nice Windows UI. Components, color codes. Brown, black, brown, gold. Yeah, that's 100 ohms. So 40 ohms across that. There's going to be something in parallel with it. Yeah, let's just cross compare that with the R37 on the other channel. If we've got 40 ohms there, I'm going to say that's okay. Come on. What? That's looking weird. Oh wait, that's the one I want to measure. Give me 40 ohms. 40 ohms, so that's alright. I haven't watched your last stream video. Check the big resistors before the main output transistors. Yeah, we've gone through all that already. Few yet haven't watched the first part. Well, to give a summary now that a few people have showed up, we did a bunch of measurements. We tried taking out the power transistors for the channels, and when we removed, this is the channel that's not working. When we removed the power transistors, it started working fine as long as there's no load. Then I took and installed the power transistors from the working channel into the broken channel, and the issue returned. So there's something in the driver stage. What it is though, I'm not too sure. There's a bunch of components you can't really measure with a board mounted in the amplifier, so I'm just going to start by measuring random resistors basically. Because those are easy to measure. All the transistors are pretty much impossible to measure while the board is sitting in the device. It could also be R51, I believe. The labels are really difficult to read on this, since they are stuck underneath the components. R51. Where are you? Where is R51? This is gonna be the... No, it's not the big one, it's called the coil. What is your first name if you feel uncomfortable to disclose it? Ludwig. Pre-drivers, this could be anything. I'm measuring passive at the moment. There's R52. And it measures 33 ohms, and that's what it's labeled, so that's going to be fine. And I want to check R46, anything which could cause a high resistance to from the power rail to the driver transistors. And if all this stuff checks out, then we need to check the transistors, but we need R46, and that's that. But yeah, we're only missing the positive half of a waveform, so it's going to be on the positive side, most likely, of the issue. That measures 10 ohms, it's labelled brown, black, black, so that's going to be 10 ohms. Yeah, this is looking mighty fine. This is looking mighty fine indeed. We do have a nice mirrored layout on this thing. We can pretty much draw a line between here, and you've got the positive side on that side and negative side on that side, which makes for easy comparative probing, since it's obviously going to be symmetrical, everything. I didn't even think about that last time I worked on this thing. Connection, please. Can you guys even see the multimeter? Yeah, that's as good as it's going to get. I only see one toroidal transformer. Yes. Have you checked pre-drivers? I haven't measured much transistors at all. I want to eliminate the passives first, because they're so cumbersome to measure, all these small transistors. I'm not sure of the pinouts on them either, but I believe it would be... Let's see. Yeah, drivers are T19, By the way, if you go to Hi-Fi Engine, you can find a Swedish schematic for this if you want to keep up. It's called the Sentec PA-77. But yeah, it could be T19, could be T15, or rather T16 and T20. Those are, I would say, those are quite prime suspects for the time being. And I think we need to move on to checking transistors, because the most possible, most likely, resistors and passives and diodes seem to be checking out. So let's just get this board out, desolder the signal wire for the 20th time, and see what we have. And we also have a bunch of awful tantalums sitting around this thing, which need to be replaced, but I don't think those are the issue, since we're seeing like 1/2 of a waveform missing, and they would all be causing total signal loss if they were bad. I've never seen a tantalum fail in a way where it becomes a diode. Hopefully you are not measuring the resistors in the circuit. Yes, I am. Why would I not be measuring the resistors? They're quite critical. If you mean in circuit, then of course we're not going to measure. There's a risk of there being something in parallel with them, but I can do comparative measurements between the two channels, since I've got a working channel as well, so we'll have a very good reference for that. And well, let's see where we've got our driver transistors. Our driver transistors are would be here. I really need to get one of these cheap eBay transistor testers. They are a godsend. 0.2 volts between there. That doesn't look. That looks weird. How's that compared to the other channel? Yeah, that's very similar. Must be a resistor across it. Do we have a resistor between two pins on the driver transistor? Yes, we do. R49. So some resistance is to be expected. Yeah, it's pretty much impossible to test these transistors properly in circuit. I'm just going to take them out. Solder. Where is my solder? There's my solder. How much of a big resistor is measured? I don't know. Fair point, could check those, but we have a couple of kind of weird power resistors in this thing. I'm not certain what the purpose is. We'll just cross-check them. That is a fair point made by the chat. I'm leaning towards some kind of semiconductor at the moment, though. That's a short because there's a coil there, so that's fine. That's a short because there's a coil there, that's fine. And I have checked the emitter resistors. Yeah. One line. This could actually be a series resistor with everything. A power resistor, I don't know which number it is, but it looks fine. 10 ohms, as one would expect it to be. On the other side, 10 ohms, yeah, it's fine. We're taking out the transistors. I need to stop listening to the chat. There's one driver transistor. Let's just see if that checks out. Show me your voltage drops. Point 6. 0.6. And what happens if we short 2 pins? It turns on. This is looking fine by the multimeter, but that could still be an issue. That could still be an issue. Let's just put that back so I don't forget which one it is. Granted, it is unlikely that we'd be able to measure an error, since it seems to be working fine as long as it's not loaded. So really, I'm just going to go ahead and I'm not really sure what I'm going to do. I could just start swapping over transistors from the other channel, but that would take forever. Yeah, let's just swap driver transistors between the channels. Let's just swap driver transistors. Load it out of circuit to test it properly. I can't be bothered. I don't have a proper transistor tester around here. So that's one white marking. This guy gets 2 white markings. This guy gets 3 white markings. One, 2, 3. And this guy gets no white markings. That way we don't confuse them. Have you checked the capacitors and diodes? Yes. This is not going to be a capacitor problem. It's very unlikely, since the power supply is fine. And if we look at the schematic, I don't think there's any actual AC coupling cap which would affect only one channel, or rather only one half of a waveform. It would affect both, most likely. Well, actually, C7 could be shorted. And if C7 is shorted, then that could cause issues. That could cause issues. So that would be C8. I think that might be one of the horrible tunnel lamps. Oh no. It's a ceramic, so let's check that. Let's check C8. Because that could very conceivably cause one half of the waveform to disappear. Granted, you would expect it to disappear no matter which transistors you have installed, though, since it's just an input coupling cap, pretty much. Let's see what we get. Are you shorted? You are not shorted. Do you work? .07 nanofarads. I need to verify what C7 and C8 are supposed to be. Back in a sec. Well, that's 47 picos, so that's not going to show up on my meter. That is not going to show up on the meter. How annoying. But since it's not shorted, I'm going to figure that's likely okay. I could just replace it, but I can't be bothered finding my ceramic cap stacks. There you go back there. I don't think you have a problem. Would an RCL LCR meter help you here? Yes, it would. That magical transistor tester on the computer doesn't do tiny caps, so that one wouldn't help me much at all. I'm still leaning towards transistors, so I'm just going to go ahead and swap the drive transistors. Since one of these isn't working right, then it would make sense for the waveform to fail when they're loaded down. Or did I just solder the wrong thing? Yes, I did. Oh well. There we go. I'll just... So which one is which? T20, so that would be the equivalent of T19, and that's going to be T18, so that can be the equivalent of T17, right? We've got T19, T17, yeah. The way they've labelled this board is one channel has every component number is incremented by 1 on the other channel, so T19 on one channel is T20 on the other. So that's T19, that's going to be T20. Well, that's weird. Oh no, it's not weird. I guess it's weird. They're mounted in different directions. Why would that be? Are these the same? Metal chem transistors in heat sinks. This one I can see 80. This one's got 40. I have no idea what these are supposed to be. Alright, one is BFT40, the other one's BFT80. This is 80. So the 80 should go in... 80 is T19 and T20. Alright. Fair enough. There could be a mounting error. I mean, it's not impossible for this amplifier to never have worked ever. I mean, I don't know for certain. It's had this issue for as long as I've been using it. So for all I know, this was never correctly assembled. This is annoying. This is annoying. This board is not balancing very well. Hey, I didn't get around to watching the last live stream. Could you update me, please? This is an audio amplifier. It has an issue where when the power transistors are installed and loaded down, one half of a waveform on one channel disappears. And we did a bunch of diagnostics last time. I was very tired, I didn't do a very good job. But now I'm just swapping transistors between the channels to basically do that until it starts working. Because when we swap a transistor from the working channel to the broken channel and it starts working, then we've found the issue. So that is... Well, let's verify that this is the right one as well. This should be a BFT40. And I can only see 0. Yeah, we need to pop the heatsink on this. I don't trust that these are correctly assembled. Where are my pliers? Wow, the power is really unstable tonight. Lights are blinking. UPS is turning on and off. BFT40. I think that's correct. Is that correct? Let's verify. T18. That's a BFT40. It's the right transistor. You go in there. Looks like you're struggling. Get yourself a helping hand. I have them, but they're too much bother to use for stuff like this. There we go. There we go. So now we've swapped the driver transistors. And I don't think the other channels are going to explode if they're not there. because they're just another current gain stage. Yeah, literally just another current gain stage, so the other channel's just going to do fine without them. I was a bit AFK. I asked if could you use a oscilloscope for checking waveform if you did that. Yeah, we did that a lot in the last live stream. And I've got the oscilloscope powered up, and we're going to be having a look at that in a moment when we test this thing, because it should be ready to go. There's a decent chance it's going to work now. There's also a decent chance it's not going to work. Since I don't have a proper transistor tester, it's just easiest to try as you go. It's very nice in this particular case, since this device, rather the fault in this amplifier, doesn't cause it to explode. It just causes it to not work right. So I can freely swap around components without having to worry about my good component going bang. Which is very nice. It's a rare luxury. I haven't touched my setup from the last stream. 57 people watching. Yeah, 57 people watching. That's nice. Hello all 57 of you. Welcome to Vintage Audio Live Repair. Hardly the most exciting show in the world. Wow. The entire amplifier assembly is just not installed very tight. Seems the board mains are not attached to the case properly. Do you have one of them component testers where you put the item in and pressing the button and it tells you? No, I don't. I should get a couple of those. They are very cheap. Very cheap indeed. I have them at work. They're excellent. Excellent tools. And the construction, like the little LCD meters you see everywhere, the construction is so simple that not even the Chinese managed to build them wrong. Let's see. Which power cord is which device? This is the power amplifier. You go there. This is the preamplifier. You go there. Preamplifier's on. We've got a signal going in, volume. Oh yeah, we need to solder the signal wire back again for the 100th time. Alright, I think we should be able to power this up. Let's just connect the scope to the output and I'll give you guys a view of that in the webcam if I can manage. Let's see. Let's see. Let's be professional. Let's use professional camera mounting tools, such as packing tape. There we go. That's good. That's an excellent angle. Rightio, let's pair this thing on and Make sure we don't have any short circuits. I want you to be ground. Right, let's hope it doesn't explode. Oh yeah. Power on. And that looks like a fine sine wave. That looked like a fine sine wave to me. We don't have any thermal pace on the transistors, so we don't want to turn it up too high, but yeah, we're at half a volt per division, so this is fine. We can get, I've got to go, you can't see it, but we're going through distortion analyzer as well, so let's just do 1 watt of output, like so, check the distortion, and yeah, we've got 0.11% distortion at 1 watt. So we have found our issue. We need to substitute our driver transistors. That is excellent. That is most excellent. That only took like 3 hours of troubleshooting to figure out. But we're in no hurry around here, are we? Let's get rid of the 230 volts. Right, now we just need to figure out replacement for the BFT 80 and BFT 40 transistors. So, wait, what was wrong? The driver transistors, because I just substituted the driver transistors from the working channel with the one from the broken channel to the broken channel, and it started working. So these guys are the issue, at least one of them. Driver transistors. Damn, it would have been more interesting if it was not. I was pretty certain it was going to be something like this, since it wasn't exploding. It's usually more interesting when things explode. BFT 40. Let's see if we can even find a datasheet for these. There's something on all datasheet. This looks wrong. This looks entirely wrong. TO39 metal package, that could be. Alright, that looks pretty alright. 60 volts, 1 amp, 0.8 watts. Wow. That's... oh, this is one of these horrible Chinese data sheets. You don't... oh no, we do get a gain range. HFE 75 to 250s. 100 megahertz. This is a really basic transistor. Let's see if I have any suitable replacements in my transistor box. What do we have? I should have a bunch of general purpose drive transistor replacements. It should be these guys. 2SC4793. I think I used these in pretty much everything. They're like... they should be pretty alright. I'm just not certain about the gain range. They should be like 250 volt rated and like a few tenths of watts. 2SC 4793. Hello, I'm now watching. Hello. Can I send you a component tester? You're free. Just send me an email. You can find my email address at my channel page, and I'll get back to you. tip 3055 and tip 2955, those transistors have nothing to do with this amplifier. Use BD139. Yeah, that could perhaps work. I don't think I have any though. Let's see. TSC4793, 230 volts rated. That's enough. 1 amp, that's enough. What's our HFE rating? 100 to 320, so that's enough. These could work, but they are way overkill. Yeah, I could probably install these with bloody power transistors. I'm just gonna scurry off for a moment and see if I've got anything in the junk bin. Back in a minute. And the answer says nope. So we're just going to use these super overkill transistors. That doesn't hurt. They're just going to last longer. What's happened since the previous video? I'm not going to summarize again. We're fixing this amplifier. We found the issue to driver transistor. So let's see what our pin 8 for the BFT40 might be. I'm going to replace all of the transistors. These are the complements. All 4 driver transistors are getting replaced, just to keep everything matched and nice. 2SA1837. I need to get more of these. They're lovely transistors. I've used them in like that ancient video, that giant Yamaha P2200. So here's our PNPs, 2 1837s, but we want our pin 8s BCE. So what's the... we need to get the board 8 so I can do this right away. I'm horrible at remembering pin 8s. I am so bad. Let's... BFT, yeah, can be replaced by... yeah, I don't care. I've got my replacements. Oh yeah, we need to unsolder our signal input once more. There we go. Preamp is off. Just Stay in place, please. Right. So the BFT40 is an NPN. That means it's getting replaced by a 4793. 2SC4793. And our pin out according to this datasheet, which I am going to verify, is... Well, that's excellent. The Chrome PDF viewer does not allow you to zoom in. Thank you. Thank you, Chrome. You lovely web browser, which you are forced to use if you want to use YouTube. But we've got the base on the middle pin, collector at pin 3. Let's just check that with this guy. They all tested pretty much fine, which makes sense since they only malfunction under load. BFT40. So our base should be the middle pin. Where's my multimeter? There's my multimeter. Base 0.64, and that would be 0.65. Yeah, that looks like the base. Oh, hang on. Is that conducting both ways? No. No, I'm just measuring wrong. I'm just measuring wrong because I have no idea what I'm doing. Our emitter should be on pin 1. So if I showed those two together, we should see a lower voltage drop, and we do. And if I do the other way around, I don't think we should. Oh, but we do. Yeah. I'm horrible at testing transistors. It's so much easier to just rely on a cheap Chinese meter. But it does make sense if we look at the coupling about the base is in the middle, because the base on this PCB is running off to the pre-driver stage. And the emitter, which would be pin number 1, which is down, is running to the power rail. Is that right according to the schematic? It's not right according to the schematic. This is annoying. According to this schematic, at least the way I interpret these weird transistor symbols. Oh no, it's right. It's entirely right, yeah. Alright, excellent. Yes. We are understanding these transistors. We are understanding these transistors. Apple Tech Geek, stop micaling. Please stop micaling. I know where the ban button is now and I wouldn't want to ban you. What's our pin out on these? Well, let's write it down, because I can't be bothered changing tabs on this computer all the time. So we've got B, C, E. And on the other one we've got EBC. So we want to... Oh, this is going to be a bit annoying. A bit annoying, just slightly. We want our base to be kind of in the middle-ish. I want our collector to be I'm awful at this. You need to think mirrored and non-mirrored and back and forth and turn things around, and then there's the P2B, which is mirrored from the transistors, which is mirrored, which is just terribly confusing. Base in the middle anyway. Collector goes to the power rail through a resistor. Yes. No, that's the emitter. So the collector goes to the output and the emitter goes to the power rail through a resistor. So that would mean that that is the pinout we want. Let's just jam it in there. And we want the 4793, that's the NPN, I believe. Yeah, that's the NPN. 4793 replaces the BFT40. Let's write down which transistor goes where. Where's my pen? There we go. Some scribbles. That makes everything easier. So we want to replace T17 with our 4793. And that's the wrong one. And this one's turned differently, so we put it there instead. So we've got the B in the middle. The C is going to the output, which is correct. And the E is going to the power supply rail through a resistor, and there's a resistor, and it's going straight to a capacitor. So that's right. Let's also do the same thing for the other side of the circuit. Magic smoke. No, there's not going to be any magic smoke. What brand of voltmeter is that? This is a Bryman BM869. 2SA 1837. So that's... let's say that the BFT 80 has the same pinout. It does, actually, it's obvious. This has the same pinout as the other one, so we want our B to be in the middle, our C to be towards the center of the board, and our E to be towards the... oh, this is terribly confusing. B goes to the middle pin. C goes towards the output. So we want to bend that like that way. That like that way. jam it in there. There we go. B, C, E. B, C, E. Yeah, that's correct. Let's give you guys a bit of a better view of this, actually, because you can't see anything I'm doing right now. Let's use our professional camera mounting technique. Let's see. There we go. That's better. Congrats for the correct answer. Did someone guess the driver transistors? It was pretty obvious. I wonder why he disliked the tip 3055 2955 plastic encased equivalents. I don't care about those. I just don't care. I use whatever transistors are suitable for the application and that I happen to have in stock. Today I happen to have these guys in stock, so that's what we're using. Oh yeah, I want to take out another 4973 for the other channel and put these away before I toss them onto the floor. I spent the rest of the night picking transistors up. Let's solder these in place. And let's break heavy proper solder this time. Look everyone, live soldering, which everyone keeps asking me about, which is very, very weird. But I suppose Big Clive gets tens of thousands of views on him just mounting together boards. So I suppose that's what the public wants. How do you guys highlight names? I would like to know that as well. I think you just type it. But since I'm the star of this show, I'm not demeaning myself by using the chat. Oh, cunt. Cock. Stay in place, please. Be a good board. Or don't. Knipex is a meme, by the way. This is a shit pair of pliers. Right, let's just get rid of the ones on the other side as well. The ones which were actually broken. Let's try and get them correctly as well. Has this turned off now? Yeah, this has turned off. I have a 1 hour timer on the desoldering pump. The issue is just that the 1 hour timer doesn't care if you use the desoldering pump, it just turns off once an hour no matter what you do, which is entirely stupid. Don't compare yourself to others. What you do makes you great. Well, obviously. Obviously. It's still fun to compare yourselves to big YouTube stars though, because that means I can put Big Clive in the tags and get 1 million views. Or disgruntled people who don't know what we're looking for. I'm aspiring to grow a beard like him though, so at some stage people might not even tell the difference. We need some water on the solder pad. Some people don't like the water pads and just use the brass thingy instead. I prefer to use both. The brass, like shavings, work great for removing solder, but if you have an oxidized tip, then the water sometimes works better. There we go. That's hot and clean. Rightio. Out you come. Oh, these all the wrong points again. After owning this thing, I can never ever go back to using a manual desoldering pump again. $200, very, very well spent. There we go. Right. And which one is which? The T18 is going to be the NPN. And that would be the 4793. And we want our base to be in the middle. I want our collector to be going to the power rail. No, I want our collector to be going towards the output, so we want our collector to be pointing towards the middle of the board. I want our base, collector, emitter. No. Yeah, yes, I am doing this right. I am doing this correctly. In fact, if I were smart, I'd just look at how I mounted the other channel's transistor, because I know that's right. T19, T. So, oh yeah, they're mounted the opposite. Ah, this board is confusing me. This board is very confusing. The channels are mirror images of each other. Oh no, let's not look at the other channel because that's just confusing since it's mirrored. I want our base to be in the middle. Our collector to go towards the outputs and our emitter to go to the power supply. Now that means I made the transistor this way around. And it will work fine. This will not explode. This will not explode. And the other one. Base in the middle. Collector towards the output. And the emitter towards the power supply. B. No. B, C, E. B, C, E. Yes. The trick is to bend the two outer legs backwards and the middle leg forwards. That makes everything fit. And just jam it in there. Alright. That will work. How much he needs to replace? 4 transistors. And I'm going to replace all the caps as well, because they are 40 years old. And in they go. We're approaching the moment of truth. Just got to solder these in place and we're going to be able to test this thing. Oh yeah, I need to reinstall the power transistors for this channel as well. I could probably replace the 8-bit transistors while I'm at it, but they're working fine thus far, so let's not do that. I somehow made one of these in time. Yes. You are watching live TV. Welcome, Pseudos. There we go. Now we just need to go through the very annoying process of repasting and reinstalling all the power transistors, which will be a pain. I need to go to the bathroom. Because there's no point pissing myself while doing this. Where's my marker? Where's my black marker? Back in a moment. There we go. Hey, we've gained viewers while I was away. Now, what does that tell me? Oh, could you actually hear the toilet flushing? Yeah, this microphone is quite good. And I'm in the basement, right by all the sewage pipes. We are reinstalling the power transistors. Let's just give you guys a better view since we're going to be working on the board a lot. There we go. Oh, that's a luxurious view. Can always use a bottle for bathroom. No. Sure, you go ahead and do that. Sounded like that camera was taped to a tripod or something. The webcam is taped onto another camera, which is, well, barely hanging onto a selfie stick. So we are... This is quite annoying. I should really dismount everything in order to do that, but that's a real bother. A real bother. But I need to remove the power transistors for this channel. Oh, screw it. Let's just remove the board entirely, because there's going to be so much fiddling around repasting these transistors. Let's make it cannot record. Memory card. Let's see if we can hot swap memory cards in this thing. No. Let's make a backup. That's good enough. Let's take everything to bits. Oh god. Oh wow, these wires are just a straight transformer wire. And I've been bending them back and forth. Oh god. That's not a good thing. I thought this transformer was terminated with a multi-strand wire, but I was wrong. Why is this not coming loose? Detach yourself. Yeah, that's single strand wire, magnet wire. This is multi-strand wire, which is wrapped around the posts, which is going to be awfully annoying to disassemble. Hey, chicken. Oh no, it's not wrapped around the post. What relief. There we go. Final one, I think. There we go. Our board should now be free. Free of captivity. Now we can work on it properly. You go over that. You empty shell of an amplifier. We will not need these old transistors anymore. We will need our mounting screws. And we will need our isolators. Sorry, I'm very, very late. This is the internet. It's here forever. It's your loss if you're late. Hopefully not tired yet, FF. No, I just started. To recap for anyone who's just joining us, we finished troubleshooting the board. We figured out that the issue was a couple of driver transistors, which I have since replaced with 4 more modern equivalents. And now we're just reassembling everything, putting new thermal paste on the original power transistors, and we're going to be putting everything back together. How old are you? I'm 24. So let's give you guys some zoom. There we go. Good evening, FF. Good evening, Saki Bugger. I think I'm the youngest here, only 16. Well, the younger you learn. I wasn't watching stuff like this when I was 16. Granted, YouTube wasn't really much of a thing back then. The original owner of this didn't do too good of a job pasting these transistors, but I don't think this thing's lived a very harsh life. What's in the syringe? Why are you putting fluid on there? What's in the syringe? What's in the syringe? What's in the syringe? What is that fluid? Oxide. I have no idea what they've done to this heatsink, but it's awfully dirty. Awfully dirty despite being inside the amplifier, which has no vent holes. That's weird. Oh well. It almost looks like mold. No, it can't be mold because it's only on one side. Oh well. Ah, yeah, oh god. We need to clean up the insulating plates, which is a horrible job. I absolutely hate cleaning up insulating plates. Handy dandy roll of toilet paper. I usually have a big roll of paper up there somewhere, but I've forgotten to buy more paper for a few months. Remove that angle and put fresh paste between heatsink and bracket. Yeah, I'm going to do that. I am going to do that. Because that paste is not going to be any newer than the paste on the transistors. And probably not better applied either. Why is 76 people watching? Hey, by the way, if you guys could give this stream a thumbs up if you like it, that would be interesting to see, because we're going to be here for a while, and currently I think YouTube is basically rewarding live streams with exposure live as they go, given how many thumbs up they get. Because in the HP laptop repair stream I did, it got an insane amount of views right away, and it kept getting that over time. That I'm quite sure that's to do with me shilling for likes in the middle of it, quite harshly too. And the other streams I've done, which haven't received as many live likes, have not performed as well. So we have a bit of a baseline for an experiment here. If we can get like a considerable number of likes on this and it does very well, then I know that I need to start shilling for likes like everyone else. Which is a real shame, by the way. I don't like that YouTube's doing that, since shilling for likes is obviously going to be the end result of them valuing likes so stupidly high and basically rewarding people for going, hey, comment, like, subscribe, subscribe to my channel, leave a thumbs up, comment, like, subscribe. Because that shit is annoying. I already did leave a like. Excellent work. Good job. You're a hero. Where are my isolating plates? Liked. Excellent. Keep liking. I really would be curious to see how that pans out. It also is stupid how YouTube is rewarding live streaming in general, because the amount of effort I put into a live stream like this, I'm just sitting around doing what I normally do now. If I'm to film this, I would have not gotten half as far as I have now, and I'd still have to edit the video. And I think it's a real shame that you don't get rewarded as many views for actually putting down the effort to properly produce a video, because you just get so huge, ridiculously huge watch time statistics from having people watch you live. I mean, there are going to be people who've been watching this for as long as it's been running, 1 hour 23 minutes, which is almost 10 times as long as the average view on a properly edited video of mine. Which is just silly, because they are higher quality content, and I think they should be rewarded with more exposure, more, well, I guess exposure is the currency with which YouTube is operating. But no, everyone should just be live streaming, because minutes and likes, watch time and likes, that's what we want. And I suppose it does make sense from an advertiser's perspective, since it means you get to tie down the eyeballs for longer. So they might be getting a bit of a better advertising deal out of it. Can you please do a Mr. Carlson style tutorial on your HP snake oil detector, please? I have heard of Mr. Carlson, but I don't know what a Mr. Carlson style tutorial would mean. Love a messy workbench. This isn't messy. This is literally just one project, and all the ancillary things required, plus the laptop for watching YouTubes. Well, it's based on reading schematics on the laptop as well, so it is required, strictly. Alright. That was 10 minutes spent cleaning 4 plastic pieces. Just the transistors left to go. Wipey wipey, baby bottom. This must be what it feels like to be a parent. How is that HP laptop going? I haven't really touched it. But I would imagine it working fine if I were to try and pair it on now, since we found such an obvious issue. But yeah, I'm redoing some of my computery stuff and I'm trying to figure out a use for that machine. Among other things, I'm going to be moving my current HTPC down into the workshop to act as a live streaming machine. I've also ordered a couple of cheap HDMI capture cards to shove in it, so that you might actually be able to watch this on two captured HDMI streams, because I've got the microscope camera there, which could do very well for capturing the bench from straight up, rather than the dinky little webcam you're watching now. It would give me a proper zoom, which I can adjust live, and of course it's a microscope. So we could do some pretty fancy stuff with it. Pretty fancy indeed. But I need to wait, they're like $30 eBay cards. But it's very similar to the one I've got borrowed and in my capture computer at the moment, so I think they'll work fine. More wiping. We're already out of our first roll of toilet paper. Oh, and on a side note, I have actually ordered some flux. Couldn't order from Rossmann since his shipping is retardedly high to Europe, but I have ordered some from PCB Soldering, which is supposedly British-made brand-name products. So we're going to see how well that works. It's probably going to be better than that shit in my flux pen. Now use the cardboard part to clean thermal paste. That would actually... I should have done that. That would not be a bad idea, because it's some very soft cardboard on these rolls. That could actually work quite well. Quite well indeed. Ah, someone's lapped this transistor. It's ground down to the copper. Or it's just run so hot that it's gotten discoloured over time. There's something weird going on. No, I think it's just been ground down. Huh. Let's see. What? I want to show this, come on. That has been ground down. That has been ground down. Terrorist? Who's a terrorist? 9/11. What the hell are you going on about, mate? Oh well, let's see how this was intended to go together. I would imagine they want you to mount the transistors to the heatsink prior to mounting the heatsink to the board, but you can't do that because of this is a bit of an annoying construction. We should be replacing the capacitors as well before we put the board back together. 2200 microfarads, 40 volts. Oh, do I even have any suitable replacement for these? I don't think I do. These are quite tiny for being ancient. 2200 mics, 40 volt rated. Real tiny. Proper tiny. But yeah, I don't have any actual caps at all. But yeah, they're working fine for the time being, so I'm just gonna leave them there and replace them sometime in the future. Yeah. In this stream there are no mods. That is correct, because we've got like 70 viewers. So I just don't see any point in assigning mods for such a tiny amount of people. Just check the caps perhaps. Nah, they're gonna be good enough. I can't be bothered firing up the ESR meter. We could just check them with the multimeter, I suppose. It doesn't hurt, but they're gonna be good enough for just getting this thing running, I would imagine. Let's see. This is going to be 2000 plus microfarads. We've got 7000 microfarads, 4000 microfarads, and we've probably got 2 in parallel, so that's going to be exactly what you would expect. Yeah, 4000 microfarads is good enough. It is good enough. The rest are just film caps on those horrible tantalums. Perhaps I have something suitable to replace the tantalums with, I don't know. No, I don't think so, just have electrolytics. Granted, they are quality electrolytics, so yeah. I'll just replace the tantalums with electrolytics. .47 microfarads, 47 microfarads, and the other ones are unlabeled. Let's check the datasheet. C1 and C2. They are 3.3 microfarads. I don't think I have any 3.3 microfarad caps. I do not. So they are going to become 4.7. Tantalums are good until they fail, yes. But we're just going to put electrolytics in there. They're going to be good enough. They are going to be good enough. I don't like the possibility of these just going snap and going short, possibly causing further issues. That fits really well, as if it were made to go there. According to the schematic, the tunnel lamps are 47 mic. Yeah, there are 2 47s and 2 3.3s. So we're just replacing all the tunnel lamps to have them out of the way. The 47 microfarad tunnel lamps in this device are 3 volt rated, so they're extra unreliable and extra prone to getting popped by failure. What are these joints beside? They're the big snappy things. I do not want those to be half soldered, so let's resolder those. Will you fix any tube equipment? That's unlikely. Perhaps if someone wants me to fix some really fancy old tube amplifier, I might, but I've never worked with tubes. I generally don't like high voltage stuff. The 47 is on the edge of the board. .47 on the edge of a board. There we go. New caps in place. FF, you fix only what takes your interest. Yes. That is entirely true. I cannot work on boring things for the life of me. I don't see the point. Robert, I will either work on expensive things or fun things. If a thing is really expensive, then I might make an exception. Snippety, snippety. When this stream has been going for 2 hours, I need to run up and check on my TV, because I'm calibrating that. And I don't want it to sit around and burn in unnecessarily. It takes hours to calibrate. I can't believe we have continuously over 70 people watching this. It's quite insane. Anyway, that's new caps in place with tunnel lamps. And that's a piece of wire. I do not wish to have that. Out you come. Come on. There you go. I should replace the big caps. Don't have any replacements. They are good enough for the time being. I think we're more or less ready to reinstall the PA transistors. I really would like to replace the big caps before putting everything back together, but I can't be bothered ordering parts for this thing right now. But do I have any suitable parts? Do I have any like 1000? 3300, what's that? 3316, yeah, that's not gonna do. 3325. Yeah, it's not going to do. Quite a lot of viewers. Now you only need an odd 20 odd number of likes. Oh yeah, everyone should like this video, of course. Like it and I'll make more live streams, and I'll make more usual videos. Even though they're not as rewarding monetarily. Because YouTube is retard. Yeah, I don't have a replacement for these caps. We're putting everything back together as it sits right now, and I will replace those in the future. And by the future, I mean 10 years from now. Liked. Excellent work, Jen A. Jacob. Everyone should like this, because I want to figure out what happens when we just get a lot of likes. Because I want to do a comparative popularity test between my different live streams. Now I need to figure out which transistor is supposed to go where. And I have no idea which one was coupled with which. I'm thinking these are not gain matched anyway. Yeah, so who cares? Where's my schematic? There's my schematic. Let's write down which transistor goes where. Alright. So T21 is a tip 34. T20 what? T23 is a tip 33. So let's see how this goes together. I want that there. And we want T21 to be a tip 34. Paste. Let's make a mess. Ugh. Cheap thermal paste. Full of oil. Yuck. Thermal paste, thermal paste. Big mess everywhere. There we go. That's great. I'm going to be constantly wiping my fingers for the rest of the stream. Isolators going in place. Oh, that's not enough thermal paste. We need more thermal paste. Because we're not making a big enough mess yet. There we go. Come on, come on. There we go. That's excellent. That is excellent. what's in the syringe? Well, in this case it should be quite obvious what's in the syringe. And if it's not obvious to you, then you have a very dirty mind. Alright, we need more of this stuff here. No point just putting it on one side. Doesn't make a big enough mess. There we go. So T21 is a tip 34. And I need to install T3022 as well. Need to main for 280 transistors first, else we're just going to bend the board to bits. So we need more thermal paste. There we go. We're an Apple assembly line tonight. Right. So T21, 22, they are the tip 34s. So they are going there, and how the hell is this supposed to work out? How are you supposed to get these transistors in place? This is really annoying. This is not a very thought through design in this aspect. No, that's not. You need to get the screw through both the board and the heatsink and the transistor while holding everything in place. But I have no idea how they have intended you to do it. Oh. I don't think the plastic washers and these screws are anywhere near long enough. They are not. That could very well be a cause of failure for this amplifier. Because these black plastic insulating things only cover the transistor. They don't actually cover the screw going through the heatsink. So you could have some arcing from the... How is that going to work? Oh no, actually it doesn't matter since they only need to isolate the transistor because these screws are actually connected to the heatsink. Fair enough. Fair enough. Never mind, I'm lying. Still though, I would prefer to have insulators which go all the way through the heatsink. That would just feel better, but I can't be bothered finding new ones. So let's just get this in place. Where is the hole? There we go. So now we need to bolt this onto. I think we can manage to do one at a time. Yeah, that's working. Come on, thread on, please thread on. It's not threading on. Who pressed one dislike? Michael. Oh yeah, we didn't ban Michael's alt account. Let's hope he doesn't return with another one. Oh, well, there we go. That's 2 transistors bolted down. That couldn't have gone worse. But it didn't go well because one is not at all going through the board. There we go. There we go. Alright, now I just need to get the tip 30 freezing there as well. And we're going to be ready to reassemble this. I really wish I had proper replacement capacitors for this thing. Since you basically need to desolder all the leads in order to actually get the board out. It's quite annoying to actually get the board out enough to replace the caps. It's a full one night's project, that's for certain. But tonight we're just shooting for getting this thing sounding okay on both channels. And I think it's going to. Those insulating pads are around $1.50 for 100 counts. Send me some. I'm just too lazy to order stuff like that. I think about it, then I never order it. In you go. Good boy. Final transistor. Kapton tape is good. Can you actually use Kapton tape as an insulator? Does it have enough thermal, like a low enough thermal resistance? Oh, there we go. Let's just bolt those down properly and solder them. People are saying yes. I should try that sometime. Kapton tape as a thermal insulator. Or rather, Kapton tape as a thermal conductor. I need pliers. Oh yes, there's thermal paste going everywhere. I really need to take it a bit easy not to crush those 40-year-old plastic washers. Because that would be annoying. Come on. Oh, cock. Come on. There we go. That's good enough. That's good enough. Check for continuity before powering it on, yes of course. I do not trust this thing enough to just put power on it without checking if there's a short to the heatsink first. If I tell you that I'm soldering this with a tiny conical tip, I'm sure someone's going to freak out. Tiny conical tip? How dare you use a conical tip? I don't like conical tips. Why are you using a conical tip? conical tips are shit. But I like conical tips. They're sharp, you can get in anywhere. Are there any solder joints which need to be redone? Yes, these. I probably wanted to redo the big oh, cunt. They're not tacked down. I just desoldered the capacitor, which I did not intend to desolder. You go back there. Yeah, I can't be bothered resoldering them. They're going to be replaced soon enough anyway. Should do something about this broken lamp holder as well, but I'll leave that be for the time being. Alright, let's make sure we haven't shorted out transistors to the heatsink and put it back together. What is he repairing? An old audio amplifier. Let's do. No continuity. No continuity. No continuity. No continuity. This one is living on the edge though. Come on. There we go. Now all we need to do is put this back in the case and enjoy some sweet tunes. Then we're going to be recapping the preamplifier maybe. Maybe. Tighten those transistors down more. No, that would explode the plastic washers. Oh wow, this is dirty. You're a dirty little lamp, aren't you? You shouldn't be able to move the washers when tight. I know, that's why I undid it to move it. I dare say that I've fixed enough amplifiers in my day to have a reasonable idea of what I'm doing by now. I do wonder what's up with a standoff. Oh. Let's tighten that down. What's in the bottle? Water. It's my solder water. With a bit of isopropyl alcohol mixed in to prevent it from rotting. Oh, all the standoffs are coming off. This thing is literally falling apart. There we go. That's better. Yay, I arrived. Happy New Year's. Happy New Year's to you as well, Paula CM. Paula CM. In you go. Water with a little alcohol to keep it from rotting, so vodka with ice cubes that have already melted. Yes. But vodka's too expensive, I wouldn't use that. This is not lining up right. Come on. In you go. Oh, this is feeling so wrong. I need to grind the board a bit. There we go. Getting the heatsink, the board and the transistors all perfectly lined up is pretty much mission impossible. So the screws are scratching against the board and heatsink, getting a bit pinched as they go through. Oh, that's alright. It doesn't bother me. In you go. No need to replace thermal paste if the amplifier is not tested. Well, I'm pretty sure it's going to work. I am 80% confident this is going to work fine now. Can't wait for him turning the amp on. Indeed. We're getting there. I'm so confident I'm even putting all the screws in. Oh god, this board is not mounting straight. This is annoying. This is majorly annoying. I think I understand why all the screws were loose in this thing. Because it just doesn't go together straight. Yeah, we'll let that screw be a problem for the future. We're fine with 3 screws. This one is just spinning this. This is not a very good design. Oh yeah, we were going to replace the thermal paste between the heatsink and the angle bracket, but I forgot. Oh well. Yeah, that lamp holder's not going through its hole. I'm pretty sure that's turned off again. Yep, this has turned off again. Now the question is, are we going to be testing this with its own power supply or with my bench power supply? I can't be bothered hooking up a bench power supply. The soldering quality in this thing is a bit wonky in places. The wiring's not the best. There we go. Oh, that's clogged. Don't connect speakers. Now I'm connecting up my oscilloscope and my test load. Most amplifiers I work on I never listen to them ever. I just use a scope and a test load. Clean up, please. Why is it not sucking? Oh well. Camera. Wow, 81 viewers. Hello everyone. We're just reassembling this after a hopefully successful repair. Right, pins 6 and 8 are obviously ground. And I would imagine pins 5 and 7 being the inputs, or rather outputs. Speaker outputs. I'll just tack those down sloppily for a test run. Oh, that turned into a horrible big blob of solder. That is not working. That's better. How much that big roll of solder costs? I don't know. 20 euros maybe? I don't remember. Blue, red, green, red. These solid core wires are handled as staying in the right order. There we go. Have you checked the sub-drivers for the main transistors? No need, everything's working. Anyone who's just joining in, we've pretty much fixed this thing already. I think we're just reassembling it for a test run. do is resolder the input leads, and I think we'll be ready to power on. Perform a smoke color integrity check. Let's put the input signals for both channels in place, since we have replaced a bunch of stuff for both. And which side? I have no idea which is ground on these inputs. Why is that not? Why do we not have continuity to ground from one of the inputs? That makes no sense. Positive side is going straight into that one cap, so let's just put it in as the other channel and ignore the fact that we have no ground there, because it's probably intentional in order to avoid ground loops. Probably. I don't know. We'll find out. Come on. I want to look at the datasheet. The datasheet for what? The replacement transistors were 2SC4793. Alright, I think we're ready to go. I think I've installed the transistors correctly. I think a lot of things, but I have a feeling if we connect this up, it's going to work reasonably well. So let's get everything going. Input, power to preamp is in. Power amplifier, power supply. One speaker connected, volume set to minimum. Well, let's connect both speakers just for the fun of it. Where's the other one? Where's my other speaker wire? There's my other speaker wire. Snap. Wait, you turned it on. No, we haven't turned it on yet. I'm gonna give you guys a view of the oscilloscope before we do. There we go. Let's just clamp onto. Oh god. Let's throw everything on the floor. Let's clamp onto our... I don't remember which was the broken channel. Oh well. Let's say it's that one. Let's check for T23 and 24 are supposed to be T33. Yes. Alright. Preamplifier going on. And power amplifier on there. And power amplifier on there. Flames. Drawing 6 watts. 7 watts. It's not exploding. But we're not getting any signal. Why aren't we getting any signal? Why are we getting no signal? Are we getting signal on the other channel? No signal anywhere. Drawing 9 watts. 10 watts, 9 watts. There's a bit of heat in the pre-drivers. Nothing too worrisome though. Are we getting signal? Where's our signal? I think we're getting no signal from the preamplifier. Why are we getting no signal from a preamplifier? Because I didn't connect the signal. This helps. Okay. Let's try it again. Escape connected to the output. Preamp is on. Power amp is on. That's better. That's better. Let's check our output level. Let's go to like 1 watts. There we go, 1 watts. So that is 1 channel, looking fine, looking absolutely fine. Amplifier is drawing 25 watts, which is about right. That's the other one, looking fine. A bit uneven levels, but that's no biggie. I'm pretty sure that was the channel which wasn't working at all. So let's go to the distortion meter. Let's see. Distortion. Actually, let's see how big of a difference in level we actually have between the channels. One channel is right now at minus 1 dB. The other one is at minus 2 dB. Yeah, that's about 1 decibel difference, but that could be due to the volume control in the preamp. I don't think this is an issue with a power amplifier. I think let's just check the distortion level at 1 watt. So one channel's got what's that? 0.11%. The other channel's got 0.12% distortion. That's excellent. That's well within spec. Were the drivers PNP and NPN? Yes, and I replaced them with a 2SC4793 and its complementary, the 2SA1837. I think this is going to be working just fine. Nothing's exploding. Driver transistors aren't on fire. They are running somewhat warm. Might want to put some kind of heat sinking on them, but they're specified to 2 watts of power dissipation in free air. So That's good enough, I'd say. Let's put the scope on the monitor output of the distortion meter and just have a look at all the waveforms as they come and go. Let's stick to our 1 watt output. There we go. What's our distortion look like on that channel? That's some pretty pure harmonic distortion. That's looking just fine. And the other channel, a bit more high frequency guff there, but it's good enough. What's it look without the low pass filter? That looks fine, doesn't seem to be having any horrible oscillation. Bit of noise coming in, but that's going to be from that lamp for the most part. Looking fine. Both channels looking excellent at 1 watt of output. Now tested without the preamp. That's a fair point, because the last time we tried using this thing without the preamplifier, it started oscillating horribly and blowing fuses. So that is a very fair test. Let's see what happens. Let's put this on a higher range, just not below anything. Input level. Power on. No, still drawing stupid amounts of power if you do that. That's weird. That's weird. I have no idea what's causing that, actually. Let's try it one more time. Nope, it's drawing stupid amount of power. That is a very odd issue. I have no idea what's causing that. And doesn't seem to be coming out of the speaker outputs either. It's very odd. Very odd. I can see the output of the device. It's pretty much nothing coming out of it. There you see. Maybe it was just designed to be used with a preamp. No, it should run just fine with any preamplifier. It says so in the datasheet. But there's clearly something about the setup we're using here which is just causing it to not work fine. Our input is rather high impedance, so it could not be happy about that. But I think it's going to be fine if we have no input at all. It's fine, absolutely fine. What's the biasing voltage across the power transistors and the drivers? I have no idea, but it's fine if we have no signal, so I don't care. Yeah, I don't really care about that behavior, since it's going to be used with its preamplifier anyway. And we have a 1K of input to output impedance of a test jig. We could try buffering the output of the signal generator through something in order to see what's supposed to happen. Most of the impedance coming out with preamp, it's gonna be low. It's a line level device. Whereas my distortion meter is 600 ohm plus like a couple of hundred ohms in the scope probe it's connecting through. Yeah, I don't care. I honestly don't care about that issue. Let's just see how it performs with the preamplifier. Because that works fine. I'm probably going to fix it at some stage, but at the moment I don't care. Wouldn't explode it. Right. Yeah, let's see how much power we can get out of this thing. I want to disconnect the scope for that though, because that tends to obscure the results. You get to watch the distortion meter instead. Or try. No. You're not going to see anything. That's an excellent view. Let's just check the... put this on the 3% range distortion. Let's turn it up until it starts clipping. There we go, that's roughly clipping at... what's that? 16.25 volts on that channel. And that would be just over 30 watts. That's fine. Does the overload light work? Overload light does not work. Let's check the other channel. Turn it up until it clips. There we go, that's pretty much clipping. And that gives us 16.5 volts. So the channels are pretty much identical with regards to clipping power. That's excellent. But rather transistors are not catching fire from doing that, which is good. I wonder how many millivolts of bias this amp should have. Well, we're usually talking milliamps when you're talking about biasing a transistor. And I have no idea, it has no bias adjustment, so it's either hard-coded or has some kind of automatic servo thing going on. I'd say it's probably hard-coded, since this thing is so simple. But we could measure the voltage across the 8-bit resistors, just for the fun of it. Let's see. It's going to be R51. I'd wager it's those guys. Yeah. Let's just check. Yeah, those are going to be our emitter resistors. Load off. What is our bias current? We've got 2.7 millivolts across that one. Whoa! I just got very scared from the front panel moving around. So about 2.8 millivolts on that channel, 2.5. 2.5 millivolts across 0.33 ohms, 2.5 m, 0.33. That's 7.6 milliamps. Any progress from last time? Yes, the amplifier works now. Are you from Sweden? No, I'm from Finland. But yeah, this amplifier works. I want to give you guys, let's say, a couple of measurements just for the fun of it. Let's do a noise floor. So let's just do 0 input level and just measure the noise floor. Oh, that's not looking good. Oh wow, that's super noisy. That's ridiculously noisy. Is this really? That's... Let's get rid of all the 50 Hertz. Ah yeah, we've got 50 Hertz coming in through somewhere. That's... There we go, that's a more fair measurement. The noise floor from 400 Hz to 30 kHz is minus 70 decibels for the preamp and the power amp together. Both channels sitting at the same level. That's not fantastic. It's pretty noisy. This is a pretty noisy setup, but I still need to service the preamplifier, so I don't know what shape that's in. Let's disconnect this and see what the noise floor of just the power amplifier is. Oh wow. Oh wow. Oh okay. What? This power amplifier has a very impressive noise floor. We're talking... Wow. I was not expecting that. The power amplifier alone has a noise floor of 55 microvolts. That's like minus... That's below minus 80 decibels. Decibel volts. Let's just calculate that. I know that Miscal can do it. Decibels. Volts. 55 micro. That's minus 85 decibel volts. 400 Hz to 30 kHz. That's excellent. This power amplifier has a very low noise floor. Very low noise floor. We've got a fair amount of 50 Hz hum coming through, but that's, yeah, I'm going to say that's due to the test setup. But wow. 55 microvolts. And 45 on the other channel. That is quiet. That is quiet. I was not expecting this amplifier to be very quiet, but that is a very, very quiet power amplifier. Well, that's a positive surprise. That's a very positive surprise. the preamp is a noisy sod. Yes it is, but it's not serviced. It's still got all the original capacitors inside and everything. And this entire setup has a fair amount of 50 Hz coming through from somewhere, and I don't know where. So it's not perfect. But the 400 Hz to 30 kHz noise on this amplifier is wonderful. So do you think a recap of a preamp will help with the noise? I can imagine a general service of it will help with the noise. I am going to go through it. I might make a proper video about that rather than a live stream. Because I want to service this thing up properly. I really like the fact that it's such a unique amplifier. It was only ever sold in Sweden. Oh, but yeah, I think we're gonna wrap this up. Oh no, I want to do one final test. That was the clean power output test. So let's see how loud you can go on this setup without exceeding 0.1% THD plus noise. Place your bets. This thing is rated 2 times 30 watts. We'll give it the benefit of the doubt and give it a very high input signal of like over a volt. Let's give it an input signal of 1.7-ish volts. So we should be eliminating a lot of noise from the preamplifier by just giving it a huge input signal to play with. So we'll get rid of the 400 Hz high pass. Right, place your bets. Output power at 0.1% distortion. What do you think we'll get? Turning it up. At 1 kHz, of course. Let's see. There we go. Come on. We are just on the brink of clipping. There we go. And we are getting on one channel 15.25 volts. And the other channel the same exact level. 15.25 volts at 0.1% distortion, which gives us 29 watts per channel. 29 watts per channel at 0.1% distortion. Now that's pretty alright. I'm almost willing to bet that a fair amount of that is limited by the capacitors in it, since they're so old and horrid. And it's going to have a fair amount of peak capability as well, since we're pushing continuous power now. It's working quite hard. Well, that's not bad. That's not bad at all. I'm happy with that. And above all, it didn't explode or catch fire. Even with a new transistors installed with no heatsinks. In fact, let's turn it up for a while and see just how hot these guys run. Because they are running warm. They are running warm. $50 degrees. Pushing like 10 volts per channel now. About 50 on that one. $55. They're not catching fire. That's not too bad, actually. I would expect these to be running hotter. I seem to have good thermal contact with a heatsink from the angle bracket as well. No real point in replacing the thermal paste there. Outputs are running at 55 right now. Yeah, I'm gonna give that an OK. Oh, and I just figured out that balance issue we saw a while ago, why one channel was slightly off. The balance knob isn't centered. There we go. That will take care of that. Excellent. I'm gonna call that a wrap up. And I will thank you for watching. Goodbye. Look forward to a more proper video on this thing in some time. But I'm going to be doing some bench reworking here soon now that I've got this, the grunt of this work out of the way. Gonna add, let's just, I'm gonna add like a proper shelf here. So that I actually have something to clamp my cameras and shit onto. Rather than just having this whole bunch of nothing there, which is really rather annoying, a waste of space. Anyway, goodbye, cheers.